The CAP theorem, also known as Brewer's theorem, is a fundamental principle in distributed systems that describes the trade-offs that need to be made when designing and operating distributed databases or data storage systems. The theorem was formulated by computer scientist Eric Brewer in 2000. The CAP theorem states that in a distributed system, you can achieve at most two out of the following three desirable properties. Consistency, see every read request to the system receives the most recent write, or an error, in response. In other words, all nodes in the system have the same data at any given time. Availability, every request, read or write, to the system receives a response, without guarantees about the data's consistency across all nodes. Partition tolerance, the system continues to function and provide responses despite network partitions or communication failures between nodes. In simpler terms, consistency, all nodes see the same data at the same time. Availability, every request receives a response, without a guarantee of consistency. Partition tolerance, the system remains operational despite network issues that might prevent communication between nodes. According to the CAP theorem, in the presence of a network partition, P, a distributed system must choose between ensuring consistency, C, or ensuring availability, A. This means that a system cannot simultaneously provide strong consistency and high availability when faced with network partitions. Different distributed systems make different trade-offs based on their requirements and use cases. CA systems, these systems prioritize consistency and availability. They sacrifice partition tolerance. Examples include traditional relational databases that might prioritize consistency over availability in the event of network failures. CP systems, these systems prioritize consistency and partition tolerance. Availability might be compromised in the face of network partitions. Examples include systems like HBase. AP systems, these systems prioritize availability and partition tolerance. Consistency might be sacrificed to ensure that the system remains operational even during network partitions. Examples include NoSQL databases like Couchbase. It's important to note that the CAP theorem doesn't mean that a system can't achieve some level of consistency, availability, and partition tolerance. Rather, it's about the trade-offs and priorities that must be made in the face of network failures. Different systems choose different trade-offs based on their design goals and the specific requirements of the applications they support.